Hello everyone, welcome to our presentation for Management Science Assignment 1. We are Group 4. Let me briefly introduce our team members. Me, myself, Rishwin, Pavindraj, Devarishi, Tan Li Bing, Piao, and Haris. Today we will be walking you through our solution for linear programming problems, including both graphical and simplex methods. And then the next slide, I'll start with maximization question 1. Our decision variables are X for refresher fresh juice and Y for super duper fresh juice. Our objective is to maximize profit, represented by the function Z equals to 6x plus 8y. This is subject to 4 main constraints. Oranges at 3x plus 1y less than 50. Apples at 2x plus 3y less than 40. Ginger at 1x plus 0y less than 15. And watermelon at 0x plus 1y less than 10. By calculating the intercepts and testing the corner points, we determine that the maximum profit is Rm 116 and 17 cents, which occurs at x 15.01 and y equals to 3.33.
Thank you, Riswin. Moving to maximizing question 2. Our decision variable are x1 for serial A and x2 for serial B. So our objective function is z equals to 9x1 plus 10x2. We have two main constraints, which is 100x1 plus 140x2 more or equals to 480, and 150x1 plus 190x2 is lesser or equals to 700. By treating this as simultaneous equation and substituting the values, so we solve for x2 will get equals 1 and x1 will equals to 3.4. Plugging this into the objective function gives us a maximum z of 14.6. For minimization question 2, we are looking at pasta as x1 and tofu as x2. The goal is to minimize z, that z is equals to 60x1 plus 50x2. We have three constraints here, including 8x1 plus 16x2 equals to or more than 200, and 2x1 plus 2x2 equals or more than 40. After evaluating the intersecting corner points, we found that the optimal minimum value to be z is equals to 1080, which happens when x1 is equals to 8 and x2 equals to 12.
Next, let's look at the simplex method questions from the 15 April E exercise, starting with exercise 4. So the objective is to maximize z equals to 6x1 plus 4x2 plus 0s1 plus 0s2. In our first tableau, we set up our basic and select variables, that is s1 and s2. We identify that x1 as our pivot column because it has the highest positive value in the C to Z row, which is 6. S2 is our leaving variable with the smallest ratio of 6 because they are positive values in the C to Z row. This table is still not optimum. In the second tableau, x1 enters the basis. After updating our rows, we look at the C to Z row again and see a positive value of 10 per 7 under x2. This makes 22 our new pivot column. The leaving row is now x1. Since there is still a positive value, we have not reached the optimum solution yet.
In the third tableau for exercise 4, we calculate our new value. Looking at the bottom C minus Z row, our value are 0, negative 6, negative 1 over 4, and negative 1 over 2. Because there are no more positive value in this row, we can conclude that this is our optimal solution. Our final maximum value for the Z is 46, with x2 equal to 7 and x1 equal to 3. To verify our manual calculation, we ran this assembly line production problem through software QM As you can see from the iteration on the screen, the software matched our step perfectly. By iteration 3, the Cj minus Z0 has no more positive value and the optimum Z is confirmed as 46.
Now, let's move on to exercise simplex 5. The objective is to maximize Z equals to 400 x1 plus 100 x2, along with our three slack variables, which are S1, S2 and S3. In the first tableau, we identify x1 as the pivot column due to the high C minus Z value of 400. So our leaving variable is S1, which gives us the lowest ratio of 10. Moving to the second tableau, x1 replaces S1 in the basic variables column. Our current Z value jumps to 2400. However, when we evaluate the C minus Z row, we still have a positive value of 100 under the x2 column. So basically, this tells us the solution is still not optimum, making x2 our next pivot column.
I will conclude our manual calculations with the third tableau for exercise 5. After performing the row operations, we check the C minus 0 last time. The values are 0, 0, negative 10, 0, and negative 320. Since there are no positive values remaining, we have successfully found the optimum solution. The maximum Z value is 2720. Just like the previous question, we've cross-checked the Pinewood Furniture Company problem using software QUMP. The screenshot shows the progression of our CJ minus to CJ rows through the initial iterations, which aligns perfectly with the manual tableaus we've just presented. That brings us to the end of Group 4's presentation on Assignment 1. Thank you for all your time and attention.